Good afternoon, guys. My name is Carlos. I'm a web developer based in Brooklyn, New York, and today we're going to work on a project called Codestrips from the Build Web APIs from Scratch course. Now, in order to complete this project, you should be quite familiar with JavaScript and its fundamentals. We're going to be working with a lot of functions and conditionals, so you should know how they're structured, how to create functions, how to pass them around, what are scopes, how are variables set within scopes. You should also be familiar with loops, how to create loops, and how to use built-in methods to actually make our code easier to read. We're going to be working with two libraries specifically. We're going to import some other packages, but we're going to work mostly with Express and SQLite. The name of the library for SQLite is SQLite 3. So you should know how to work with Express, how to create route handlers, how middleware is used. We're going to do some error handling as well. You should know how to use SQL, how to write queries, how to grab certain rows and columns and certain information from databases. And you should be familiar with test-driven development. We're not going to be writing unit tests for this project, but we will already have some unit tests provided for us. So when we run Mocha, we'll see the failing tests. So we're going to write code to make these tests pass. And then hopefully we have all the tests passing at the end of the project. So without further ado, let's go ahead and get started with the project. Okay, so this is the Codestrips project. So let's go ahead and read a little bit about what we're going to end up doing. So Codestrips is a small application that allows users to create and save small one-pane comic strips, and we'll be able to select a head, a body, and a background location, along with a thought and or a speech bubble, and the actual text within that bubble, and a caption for the strip. So by the end of the project, we'll be able to save our own little comic strips in a SQL database and be able to retrieve them so that when we restart the server, they will still persist on the website. We're going to be using the knowledge from Express and SQLite and the SQLite 3 node module that we're going to be able to create a table and send post requests to actually create new strips and insert them into the database. And also we'll have a get route so we can actually retrieve certain strips from the database itself. Now we can run the application by typing node and the name of the file we're going to run. A lot of our code will be in app.js, so here we'll write our route handlers, all our middleware, and SQLite will just take care of starting the database and creating a table for us. So we'll be going through each step and breaking this down as in a very granular process. We also have a test suite that's provided for us in this file. You can look at the files over here. We have a test file in here, and we can run it by just simply typing Mocha, so we'll see all the tests that are failing. So just to keep in mind also that as soon as we click away from this text editor, our files will automatically save, so we don't have to save anything. It will just, as soon as we unclick somewhere else, the file will be automatically saved. Okay, so let's go on and jump straight into the first step. Okay, so for step one, we're simply going to install the Express library. So let's go ahead and type npm install Express. Let it load. Okay, perfect. So that's it for step one. And if you're curious, you can actually run the Mocha to see the test suites. I believe we have around 20 or so tests. None of them should be passing because we haven't written any code. You can see a summary of the tests and what the tests are called here. So we have basically a describe block for the Express server. We're testing the table itself, and then we're testing our handlers here. And then we'll eventually get to that. I'm going to start setting up the project here. And once we start creating a database, we can start running the test more. Okay, so for step two, inside app.js, we're going to import Express and create an instance of an Express server called app. So I'm just going to write a variable here called Express, and we're going to require that package here. And then I'm going to create an app variable here that will be an instance of our Express server here. So make sure you save that. And actually, if you run Mocha, I believe you should, I think the first test is testing whether the app exists. No, the first test is that it's testing if we're instantiating and exporting our app model here. So we have to export it here. So module.exports equal app. And then we save that. And let's just run again. I believe it should pass the first test. The other one should fail. And yeah, we get an instantiation, and we're able to export an instance of our Express server. So perfect. Let's move on to step 3. So in step 3, we're going to create a variable called port and set it equal to process.environment.port or 4001 here. So let's create our port here. Now, in many environments, even like in Heroku and as a convention, you can actually set the environment variable port to tell your web server what port to listen to. So if there's already a port created in our environment, we're setting it to that. And if it doesn't exist, we're just specifying what port for it to listen to. Okay, I'm going to go ahead and clear my terminal here actually. So let me clear that out, and we'll move on to step 4. In step 4, we're going to import body parser middleware so we can actually work with JSON bodies. So when we send post requests or when we receive them on our server, we can actually parse those requests into a JSON object and use them to update our database or modify it in any way. So we're going to install the package called body parser. So go ahead and type in body parser, npm install body parser. And I'm also going to install another package called Morgan. Morgan's quite useful to log when we make GET requests or receive POST requests on our server. Morgan kind of tidies up the way it logs our output here. So when we get a GET request, it kind of outputs a string that says what request, what route was hit, and what status code it contains, and what was the result for it, whether it was success or not. So we actually have to use that middleware here with our app instance, and we have to actually call .use on our app instance. And this will tell what middleware we're going to be using. So we're going to go ahead and first we actually need to import body parser. So let's do that here first. So body parser equals require and then the name of the package. We'll do the same for Morgan. And now we can actually start using that middleware. So if you look at the documentation for Morgan, you can actually set it to a specific type of strings where it will log out whatever you'd like. So Morgan can take format and options, and the package itself give us a lot of predefined format strings that we can actually input here. So we can put in tiny, and that will actually output a certain format, a specific format that Morgan has that will just log a very simple log of our routes. I'm going to use one called dev. Dev simply outputs some output that's colored by the response status for development use. So if we get a 400, then we'll get a red log out here that indicates that it was an error, and also has a status token that will be colored red, yellow for client errors, or we have different colors for certain different status codes. So it's very useful for our development purposes, and it's easy to catch what the logs are for our route handlers. Let's also set up our body parser. So we'll call body parser.json. So body parser is just a piece of middleware that parses information from inputs incoming from like forms, and then it stores that information in a JavaScript object that's accessible in the rec.body request body. So we were able to actually parse that into JSON, and then we can use that however we'd like once we actually parse this. So it's very handy and very useful, and this basically tells the system that you want JSON to be used. Okay, so we're all good here. Let's move on to step 5. So now we actually want to set our static directory here as public. We'll put that on top actually here above our Morgan middleware function. So to serve static files such as images or CSS files and JavaScript files, we can use this express static built-in middleware function. And this here, this argument will basically be specify the root directory from which to serve the static assets. So we should grab we'll have a public directory somewhere here, and here we'll have our static files here. Okay. We also want to start the server listening on the correct port with app.listen. We'll do that right here at the bottom at the end. So we can simply pass in app.listen. We'll pass in a callback function. One will be the port we're actually going to listen. That will be the first parameter. The second parameter will be the callback function. And in this case, I'm just going to console log a little information of what port the server is listening. I'll use template letters here. So you can simply type in something like server is listening on port, and then interpolate here the port variable. So at this point, we can actually start our server. So let's simply type in node app, and we should be logging our log here that we're listening to the port, and we can refresh our browser and should probably get some sort of output. And there we go. So these logs over here, that's basically Morgan working. As we haven't written any handlers, so of course our tests are getting 404s for these things. But now we get our actual main page here, and we're grabbing the index page here. So we're actually we're starting the server and able to actually start the application here. So you can look at, these are some options we have to create our comic strips. Right now we can't really create a strip, so this save new strip will not be working because we haven't even set up a database, but you can see an example of what our comic strip will look like. And here should eventually contain all the saved strips, but we don't have any. Like again, we haven't set up our table yet. So let's go ahead and I'm going to kill the server, and let's run Mocha as well to make sure that we're passing the first two tests. So if we look up here, we are able to instantiate and export our app or server, and we're able to listen at the correct port, which will be either process.env.port or 4001. Okay, so we got the project really nice set up. I'm going to head and clear the terminal once more. Okay, so we're looking good. Now we can start working with SQL and creating our database. So let's move on to step 6. Okay, so for step 6, we're going to install SQLite 3. And inside SQL.js, we're going to import the SQLite 3 library. So let's go ahead and install SQLite 3. Let that load. And I'm going to go ahead over here. And we're going to create a variable here called SQLite 3. And set it equal to require SQLite 3. Some packages are quite heavy, so it might take a little bit for yours to install. Unless you get, don't worry too much about the warnings. These are simple configurations when you install packages. It should be fine. Okay, that's it for step 6. Let's move on to step 7, where we're going to start actually creating a database. Now for step 7, we're going to create a variable called db and create a connection with our SQLite 3 database. Now create the connection is pretty straightforward. We're simply going to instantiate the SQLite 3 database class constructor, and we're going to pass in the path to the SQL database file that we want to connect with, which is right here. Okay, so let's make our new variable here, const db. We'll set it equal to a new instantiation of the SQLite 3.database file, and in here we can pass the exact path of the file where we're going to create. So now we can create a connection with the database. Perfect. Okay, so for step 8, we're actually going to use our connection with the database, and we're going to create a table called strip, and we're going to apply the following schema we have right over here to it. Now we could simply type in db.run, but we actually don't want to do that. What we actually want to do is wrap all SQL commands in a function called db.serialize. So db.serialize will actually take a callback function, which will be anonymous for us. And inside here is where we want to write our SQL queries. And the reason I'm doing this, because now each command inside the serialize function is guaranteed to finish executing before the next one starts. Otherwise, statements would run in parallel. So if we're trying to drop a table and create it at the same time, it would cause a lot of conflicts. So it's good to serialize these SQL commands so that they can be processed in sequence. So when we run our actual SQL queries, before we actually set our table, we want to run one command, because what if our table already exists and we're trying to change the schema of this? So before creating a table, we want to actually, if we want to change the schema, for example, and the table already exists, we want to drop the table if it exists, and we're going to specify what table we're going to drop. Okay, it's important because if we're creating a new table or we're changing the schema of the table strip and that already exists, we need to actually drop it. So this will enable us to modify the schema of the table strip if we want to do that by running the SQL file again. So now we can actually create our, oh sorry, I forgot to put run here. There we go. So now we actually can pass in our SQL query here where we're going to create our strip table. So I'm going to wrap that in backticks. I'm going to write my command here, and now I want to check if it doesn't exist, I'm going to create it. So create table. If not exists, what is the name of our table? It'll be strip. And now here's where we're going to specify the values we're going to be putting in, which are essentially the ones listed here on step 8. So we'll be going then one by one. We want an ID. That should be an integer, and it's going to be a primary key. We also want a head, lowercase. We want that to be a text and not null. We want a body, that will be text and not null as well. We want a background, that's text and not null. For bubble type, make sure you do underscores here. We'll do as well type text not null. Then for bubble text, we'll also do text not null. And if we want to add a default, you want us to add a default empty string, we just simply type in default, pass in the empty string. And lastly, we'll pass in a caption, which will be text not null, and also default an empty string. And yes, I noticed my typo here. Hopefully this is spelled correctly. I believe it is. So we'll move on to step 9. So now we can actually run our SQL file, and this will create a database in our db.sqlite database file. So let's go ahead and type in node, make sure it's lowercase, node SQL. And it doesn't give us any output, but there were no errors found. Then that means that this SQL query ran successfully and we were able to create a database connection. All right, Kurt, perfect. So I'm going to go ahead and run our Mocha unit test suite as well, just to see if anything else passed. I believe we have some about our table, and you saw a bunch of green there. Let's scroll up. Okay, so we have our server. All the tests are passing for a server. Now for our strip table, we passed in the schema here. Everything seems to be in order and all our tests pass, so we were able to create a strip table. Okay, perfect. So let's go ahead and move on to step 10. So in step 10, after creating the database, we can add 2 test strips to the database by running node.cjs in the terminal. And if your database has been set up correctly, you will see a message logging the rows that have been inserted into the strip. So we actually look at the seed file. You'll see there are just SQL queries that we're running and inserting them into a table here. So if we simply run our, let me get rid of this file here. If we just simply run node.cjs, that will create it. So let's go ahead and do that. And you can see the output here. Finish seeding. There are 2 rows now in the strip table. So now this enabled us to actually retrieve certain tables. We have a database, so if we run our application, we probably will see some output here for our saved strips. So let's go on to step 11, where we're going to start running our route handlers and using Express to actually show our information here. Okay, so for step 11 in app.js, we're going to add a new route to your application, and this new route should monitor the strips endpoint for the GET request. So let's clear the terminal one more time. And actually before that, I'm just going to start our application to see if anything showed up in our browser here. So let's go and refresh it. Nothing yet has been set up, so we haven't set up our GET handler. So let's kill the server again, and we're going to start by running our handler right here. And we'll do it above our listen port. And we're just going to start by running an empty handler right now. So we're going to do a get request to strips, and we're going to pass in our callback function with our information here. I'm going to make sure to also pass in next, since we're doing some middleware handling here. Okay, we'll leave it empty for now. So that's it for step 11. Now in step 12, we're actually going to try to access our database and retrieve all the arrays that were found in the database that we have created. So let's clear the terminal one more time. And I'm going to import the database and SQLite into app.js so we actually can grab the information from there. So I'm importing it here, and then in here I can use db.all. So db.all will actually end up grabbing an array for us to grab all the strips. So we can do that by simply typing in here db.all, and then we'll pass in our query here. So we'll do select all from the table strip. All right, perfect. That's it for step 12. We'll move on to step 13. So we're going to send back the array of all the strips and db.all callback. So we're going to create an object to send in the response and set its strips property equal to the rows returned from the database. So we're going to do some error handling, and also here the callback function will receive both the error as a first variable and then the rows. If that SQL executed properly, it will return us the rows that it actually grabbed. I'm going to use arrow functions here. So inside our callback function here, we're going to specify what happens if there's an error. Now, if there's an error from this, in this case, we want to send a status code of 500, meaning it's a server-side error and there was a problem grabbing information from the database. If we have, if you can look up on Google status codes or response codes, and you'll see a bunch of different status codes for specific responses here. So in this case, as our database is not being able to retrieve the information properly, it makes sense to set an internal server error. So I'm going to go ahead and send a status of 500. This is not completely necessary. This is in case, let's say, a client is using this website and he's also a developer and he doesn't know what went wrong. He can actually investigate the network connection and see that the response code is a 500, which lets him know that it's a server-side error. Okay, if we don't get an error, we're gonna work with the rows, and they want us to create an object to send in the response and set its strips property equal to the rows. So we can simply call res.send, which will send the object we want to grab. And they want us to call the object strips, and we'll set it to the rows that we're actually grabbing. So that's as easy as that. There we go. Okay, so if there's no error, we'll be sending the strips object here. This is actually, oh, there we go. Here. Okay, let's move on to step 14. So now that we actually have our get handler here for strips, and we already seeded our database, if we actually refresh this, then we should be able to retrieve the 2 strips that are saved in the database. Because remember, we actually created some by seeding the data, and there should be 2 stored or saved strips. So let's go ahead and run our application. And let's refresh our browser here. And there we go. We have a great day and cosmic jokes. So these are the ones that were created from the seed file, and if you're curious, you can actually even look at the seed file and see how they were inserted. So inserting into strip, we have values angry, we have the caption here, which is cosmic jokes, which is the name of this comic, and basically the text for the bubble here. So that seemed to work properly, and our get handler seems to be working properly there. Okay, so we're good with step 14. Now in step 15, we're going to actually start implementing the create strip. So I'm going to kill the server and run our Mocha once more to see if we have any passing test for a get handler here. Let's go ahead and go up again. Okay, we seem to be able to return a 200 status code and send all the rows from the strip table. We haven't set up this yet, so it'll be a second for that. Okay, I'm going to clear up my terminal one more time. Okay, in step 15, we're going to import our SQL database. We already did that in order to handle our GET request, but we're also going to set a new connection here. So we are going to actually have a test database to actually grab some certain different testing that we're going to do. So instead of passing in this instance database, let's modify it so we can actually work with our environment test database as well. Okay, that's it for step 15. Okay, in step 16 in app.js, we're going to add a new route to your application, and this new route should monitor the strips for endpoints for post requests. So when we create a new strip, we want to be able to send that information successfully to our server and have that information stored in our database. Okay, so let's go ahead and create an empty post handler for strips right below our get request. So app.post, we'll set in dash strips here. We'll send in our callback function with our rec, res, and next. And that should be it for now. And we'll move on to step 17. Okay, so for step 17, whenever we hit our post request for strips here, we want to actually validate that the strip being sent to us as a request is actually valid. And if it's not valid, we want to send a 400 response code, which means it's a bad request. So how can we actually validate the strip? Where we could actually validate it inside our post request, but that would mean we're going to be ending up writing a lot of logic inside our post request. And our post request is not really supposed to handle that kind of logic here. So I think a good idea would be to extract that logic away from the post request and make it a middleware itself where we actually do our own validation. So we know where the content, the JSON object, will be held when a response is received, when a request is received. It will be held in rec.body.strip. So we can access those key properties from that request here. So before that, let's go ahead and type in, let's start writing our middleware here. I'm going to call it validate to script, const validate, or validate strip, I guess. And you're going to pass in the parameters here, rec, res, and make sure you pass in next as a middleware, because we're going to make sure that if this is validated, we want to proceed onto the callback function from our post request. And before I even move forward, I'm going to pass it in right here, since I tend to forget myself, and make sure this is, there we go. Validate strip. I can't seem to type today, guys. Okay, I believe that's correct. Let me triple check. There we go. Okay, so what are we going to do inside our middleware here? Well, we have access to the JSON object through rec body strip, so it would make sense to actually simply store that in the variable, so it will be easier to access the properties from there. So let's make a variable called strip to create and set it equal to rec body.strip. And now we can actually write our conditional here. So our conditional should be an if statement, and we want to know that if any of these properties do not exist, then we send the send status. Otherwise, we're going to hit the next. We're going to call next on the middleware, and it will proceed to the code block here from the post request. So we can simply do our if statement here. And what are we testing? Well, we want to make sure that strip to create dot head, for example, does not exist. And we're using the exclamation mark to make sure that this is actually false. And I'm going to grab this section here. And we're going to do the same to body, bubble type, and background as well. So we'll simply do that and call it on body. Make sure that we're using the or statement, not the and, because we just want to make sure that at least one of them does not exist. Okay, we'll do that for bubble type, and we'll do that for background. And once again, we don't need to do it for bubble text or caption, because if they don't include that, it will just default to an empty string. So if any of this is hit, then we want to actually send a response status of 400. So let's make our response here. We'll do a return. So we actually end the function, and we'll do send status 400 here. And that's simply a bad request. You can look up more response codes if you're curious. You can probably find them on Google here. Okay, so we're sending that middleware. Okay, we're looking good then. Let's move on to step 18. Okay, now in our post request here, we're actually going to start inserting our data into the database. So how are we going to do that? Well, let's simply start by grabbing the same variable here, const strip to create, because it will be easier to access it the same way we actually grab that here. So let's say someone sends up a request, and this is valid. They included a head, body, bubble type, and background. So now we're moving here, and now we actually want to grab those values that they sent and insert those values into our table strip. So we can simply call db.run and insert our SQL query there. So let's go SQL, let's do db.run, and we'll pass in our SQL query. I'm actually going to make this a new line here. So we're going to insert into strip, and we're going to insert into these columns. So we're going to grab head, body, bubble type, background, bubble text, and caption. So I'm actually going to expand this so we can see a little bit more. Okay, here we go. Let me scroll back down here. Okay, so we're going to insert into the columns head, and make sure this is lowercase, head, body, bubble type. Make sure you use the proper name of the column in the table. In the SQL table, we identified it as bubble underscore type and bubble underscore text. If you do the capital letter between, you're going to get an error there. So bubble text, bubble text, and caption, missing background. Okay, there we go. Okay, now that we have what we're going to insert to, we actually have to specify what values we're going to insert. So let's go into a new line here. We'll insert values. Since we don't know the values, we can't really hard code this. I'm going to pass in what we would interpolate, a little interpolation with SQL and Node. So we can pass in the variables that we're going to be interpolating, and I'm just going to prepend a $sign to indicate that these are the variables that we're going to interpolate. So I'll do the same thing as head, body, and in this case we can actually type in bubble type. Since this is we're not referencing the name of the column, this is simply a variable name that we're going to be defining afterwards. So we can call it bubble type like that. I do background, let's do bubble text, and lastly we'll do caption. So how do we interpolate this? Well, we can pass in an object, and inside this object we'll be able to define as a key property what head will be. We'll pass in head as a key value, so it can be head, and we can reference the request that was sent to us by accessing this variable. So we can simply call strip to create and call .head on that. So we'll receive the .head property from that object. So we'll do the same for all of the values here. We'll do the same for body. So I'm going to grab and copy paste this as well with the period here. It's just easier to type it out. Strip head, we'll do body. We'll do bubble type. Remember, I'm referencing this here, the value, not the column name. So I'll do bubble type. We'll do background. We'll do bubble text. Same thing. And lastly, we'll grab a caption. Okay, that looks good. And that's it for step 18. Okay, now we're going to do some handling of the error. So if an error occurs during this post request, we got to actually handle that. So we can do that by passing in a callback function right after our insertion. And remember, the first argument in the callback functions will always be the error. So we got to handle that first. So let's go ahead and make a new line here. We'll pass in the function error. And we got to figure out if there's an error, what are we going to do? We're going to stop it by returning, and then we're going to send a status code of 500. So send status, and then we'll pass in 500. And this is simply internal server error, meaning that there was a problem, meaning there was a problem on our side, on the server side. Perhaps we couldn't access the database and insert these values into it. There could be a plethora of reasons, but this means it's the client actually sent validated information. We were just unable to insert it and update our SQL table. Okay, so that's it for step 19. Let's move on forward to step 20. Okay, so for step 20, we're going to find the newly created strip if there was no error occurred. Let me grab this a little further up here. And we'll have to get the proper row from the database with another query. And we can do that right after our callback function right over here. If there is no error, then we can proceed. Let me make a space here. We can proceed by retrieving our row, the row we just created. So remember that in after our DB run, we have a callback option that we can actually access the this property. So this will actually refer to the object return from this run. And this actually has a few properties, one of them being last ID, meaning it would refer to the last object inserted into the table. So we need, in order to actually grab this, we have to do another query. So we can usually use db.get. which will grab us one value here, and we can pass our SQL query in here. So let me do the backticks here, because we're going to do some interpolation, and we'll do select all the columns, everything from the table strip, where, and remember we have specific IDs for all of our code strips being inserted. They have an integer was the primary key, so it's unique for every single code strip. So let's go back here, where the ID is equal to, and we can refer to this due to the callback function after run, and we can grab last ID. So that will refer to the last object inserted into it. And from there, we can actually do some, pass in another callback function, and we'll do some error handling there, but that will be in the next step. Okay, step 21, we're going to send a 201 status code and then send the created strip inside the callback of your db.get call. Now we're going to create an object to send in the response and set its strip property equal to the strip returned from the database. So this will be the row that's returned from this call here. So we're going to send this object in the response. Okay, so from here, from making this query dbget, we can pass in a callback function where the first parameter will be the error itself that we'll handle, and the row if we actually find it. So we actually want to see if there's no row returned. If there's no row found, then we send another response. We got to kill it. We got to send a status of 500 again, status 500, to ensure that it's an actually back-end problem, a server-side problem, another internal server error. And if it's no error found, then we can actually send a 201 status, and we can chain our object here. Instead of passing another rest.send, we can simply chain a send call here and then pass in the object we want. Now they want us to send, what they asked is to send a strip property, so we'll call this property strip. And what are we sending? We're sending the specific row that we got back from the callback function. So we'll call row over here, and that should be it. Okay, awesome. So let's go ahead and open up your terminal. We'll run Mocha and see if all our tests pass. It's waiting on the post request. It seems that they found an error. We'll wait to see what exactly we got. I know what the error is. We forgot to actually pass in next here. So what's going on, it's validating the strips, but it doesn't know where to go, so it's getting timed out. There's a timeout exceeded. So we have to make sure to write next after you actually pass in your middleware. So let's try and type in Mocha again. And I believe our test should pass. Awesome. So let's bring out our browser. We'll start our app. Let's refresh our browser here. Okay, now we can create a new code strip. So we get our Morgans here. We're going to see our Morgan post log a post request when you actually save a new strip here. So let's make a quick example here. We'll say whatever head, whatever body. We'll do a square bubble here. We'll do a pyramid looking background. We'll type a text. We'll say Codestrips test text, I guess. Caption, Codestrip test caption. And let's just save that. Save new strip. And then boom, you can see Morgan logging a post request to strips. It was a 201 indicating that it was a success. And it is stored here. So it actually should persist in our database. So if we kill our database and we start it up again, let me call up node app, and we refresh our browser, we should expect Codestrip test caption to still be there. So let's go ahead and refresh our browser. And that was a success. So awesome. That's the end of our project here. If you actually want to see a solution, you can download it here from the bottom of the last step. So we went through a lot of what we went through in the previous units for this project. Our application here is not a very large scale application, but it implements a lot of stuff from different packages, from different databases, different kind of ways of implementing test code. We saw how to run validation and creating your own middleware. you can create as much middleware as you like. Eventually, you can even extract more and create a folder that has maybe a middleware folder or utilities folder where you have a bunch of different types of middleware. This is a very good template or like boilerplate of how CRUD applications will run. And even though we only did a GET and POST request, this kind of knowledge still applies to a lot of different route handlers. We also went into SQL and saw how to actually create a database, and remember how important serialize is in order to run queries in sequence and avoid running them in parallel. Because let's say you have a SQL here that that inserts something, and there's another SQL query that creates a table into that previous insertion table. But if we don't have serialize, it will run them in parallel, and you can't insert something that hasn't been created yet. So it's important to actually use serialize for these situations, and make sure you actually implement them in your future projects. But that concludes our project for today. Feel free to experiment and create your own code strips if you like. And if you want to look around into a little more depth into the code, you can click that directory in the top left and see some of the tests here if you're curious about the test-driven development. If you actually taken our test-driven development course, this might look a little familiar for you, and feel free to check it out. Anyway, thank you for watching, guys, and I'll see you guys next time.